Hey everyone. So I just want to quickly go over what exactly is a limit. All a limit is asking is what is my function approaching as x approaches a certain value? So let's say, for example, I had a function f at x is equal to x minus 2 over x minus 2. And if you've done your fair share of pre-calculus, you would know that this translates to f at x equals to 1 such that x does not equal to 2. Now, if I asked you to evaluate f at 2, you would do 2 minus 2 over 2 minus 2, which is equal to 0 over 0, which is undefined. However, what you can do, so you can't really do that, right? But what you can do is you can ask, what does f at x approach as, what does f at x approach as x approaches 2? And the way we write this out formally is the limit of f at x as x approaches 2. And the way we do this is we just ask ourselves, well, what does f at x approach, right? So if we just draw out a Cartesian coordinate plane like so, um, we have x equal to 1, 2, -1, -2, 1, 2, would have a graph that kind of looks something like this. And we see that we can't exactly evaluate f at 2, but we can see, hey, as we approach it from the left-hand side, f at x is equal to 2, or sorry, f at x is equal to 1. As we approach x equals to 2 from the right-hand side, f at x also approaches 1. So the answer to this question is the limit of x approaches 2 of f at x is equal to 1. Now, let's do another example. So let's say I had a function f at x is equal to x squared if x does not equal to 2, and 1 if x is equal to 2. So when we graph this out, it will look a little something like this. And let's say 1, 2, 1, 2, 3. My scale's a bit messed up, but I hope you get the idea. And we would have a discontinuity here, and x equal to 2, with a point here. So you can evaluate f at 2, or sorry, yeah, f at 2. So f at 2 is equal to 1. But what if I asked you what is the limit of x approaches 2 of f at x? So we look at the graph here, and we look at what this number approaches. Not what it is at 2, but what does it approach as x equals to 2. So if we approach it from the left-hand side over here, we can see that f at x approaches 4 from the left-hand side. And if we go from the right-hand side, we see the same thing. We see that f at x approaches 4 from left-hand side and from right-hand side. So our answer to this question of limit of x approaches 2 of f at x, this would equal to 4. And we can kind of do this with the calculator as well, right? So instead of asking what is f at 2, we say, hey, what if I substitute numbers that are really, really close to 2, but not exactly at 2? What is my function approach? So if we write out, I'm going to use my calculator. I suggest you use your calculator as well. Let's say I had like, you know, f at 1.99. This would equal to 3.9601. I had like 1.999. F at 1.999. This would equal to 3.996001. and f at 1.9999999, this would equal to almost, just almost, like 3.99999, blah, 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 right? If I had like f at 2.01, this would give me 2.01 multiplied by 2 point, sorry, 2.01, 2.01. This would give me 4.0602, and we have like f at 2.000001. This would give me something like 4.0000 dot 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 dot. Right, so we see that as we get closer and closer to 2, f at 2 approaches 4. So that's just a brief introduction as to what a limit is. All we're asking is, what does a function's value approach when x approaches a certain value?